Very good evening, my dear students, and those who are viewing this video. I'm Ashwini Gupta, and here I'm just going to derive the relation that is, the law of conservation of energy. We will take an example through which we will derive the conservation of energy concept. As we all know that according to the law of conservation of energy, energy neither be created nor be destroyed. Only the transformation of energy is done from one form to another form, right? So we will take an example and we will solve it. We will see how the conservation of energy is being done, right? So for that, first of all, we take an example, and suppose that example is taken as a free falling body. This is the best example to explain the concept of the conservation of energy, in which our body is falling from a body that suppose this point, and now this body is falling towards the ground under the gravitational pull, right? This is a freely falling body what we have chosen. This is the suppose height h. This is the first case, and after some time, let us suppose this body is being transferred, this being has covered the distance is here, like second case, it is a second case, and the third case will be like a body is just going to reach strike the ground. This is the third case, right? What we did is, please understand the situation. What we are going to understand is a body is thrown, or we can say it is released from certain height. Let it is suppose h height, and the first case the body was at a position, right? And after interval of time t, let us suppose this body has traveled this particular distance of x unit, and this is the situation b. Second, the location of the body is at b, and after some time interval the body has raised at the surface of the ground. This is suppose represented by c. Now if we consider all the things, the initial velocity of the body at a, initial velocity will be 0 meter per second. The velocity at b, let us suppose that is vb, and the velocity at c, let us suppose vc, meter per second, right? This is the basic concept behind this example. Okay, so we have taken three different situations of a particular body which is moving downward, the situation a, b and c. There are three special cases. So how we are going to derive the conservation of energy here? According to the conservation of energy, that is law of conservation of energy, says that the total energy of a system remains conserved, or we can say it is totally constant, right? This is your statement. Now we will prove that the total energy of the body at a, b and c are still same. Yes, it may be that the potential energy may decrease and kinetic energy may increase. ये पॉसिबल है, बट जो सेकंड ये जो लॉ है, दिस लॉ सेज दैट बेसिकली इन तीनों पर टोटल एनर्जी आपकी कांस्टेंट होगी, राइट? क्लियर है? ये तीनों कांस्टेंट होंगे तीनों पॉइंट्स पर, बट पोटेंशियल एनर्जी बदल सकती है, काइनेटिक एनर्जी बदल सकती है, लेकिन जब इनका एल्जेब्रिक सम होगा, जब इन दोनों का सम होगा, जो टोटल एनर्जी होगी वो नहीं बदलेगी. ठीक है, दिस इज कॉल्ड लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। मैंने यहाँ टॉपिक नहीं लिखा हुआ है, आप चाहें तो एक साइड में लिख सकते हैं फिलहाल, है ना। दैट इज लॉ ऑफ कंजर्वेशन ऑफ एनर्जी हम पढ़ रहे हैं। चलिए, तो यहाँ पर मैं बात करता हूँ फर्स्ट केस, व्हेन द बॉडी इज एट ए। जब आपकी बॉडी कहाँ पर है बेटा, ए पर। व्हेन द बॉडी इज एट ए, इफ वी सी हियर द potential energy PE is equal to mgh. H is the height, and as we know the formula for potential energy is mgh, right? And the kinetic energy here, the kinetic energy ke, it will be 0. Why this is going to be 0? Because of the body is just being released from that point A, and when the body is just going to be released, the initial velocity of the body is 0, and if the body do not have any velocity, then we say that they do not possess the kinetic energy. भाई अगर आप याद करो फार्मूला क्या है काइनेटिक एनर्जी का, काइनेटिक एनर्जी का फार्मूला होता है 1/2 mv², है ना। चूंकि यहाँ पर वेलोसिटी कितनी है, 0 है ना, हियर द वेलोसिटी इज 0। सो अगर वेलोसिटी 0 है तो यहाँ पे जब वैल्यू रखोगे तो ये टर्म 0 हो जाएगा। सो हियर इफ वी गो फॉर द टोटल एनर्जी, सो द टोटल एनर्जी इज व्हाट, total energy is sum of potential energy plus kinetic energy. This becomes mgh plus 0, or we can say, मैं इसको थोड़ा सा अलग कलर से रिप्रेजेंट कर देता हूँ। यहाँ से क्या निकल कर आ रहा है, टोटल एनर्जी इज इक्वल टू mgh। ये क्या है, दिस इज द फर्स्ट एग्जाम्पल, equation number first. It was the total energy at point A. Okay, now the second is total energy at B. Total energy at B. So if we see the total energy at B के लिए, first of all the potential energy, मैं शॉर्ट में लिख रहा हूँ, ठीक है, PE that is potential energy at B। ये A के केस में बात हो गई, ठीक है ना, ये A पर था। चलो B पर अगर हम बात करें, it will be mg। now the height is being reduced by x factor, by total distance h थी, we have covered this distance ax. Now the remaining distance is what? The remaining distance is h minus x. h minus x. So where we'll put here h minus x, right? Sure. Kinetic energy at B will be 1/2 mvb square. Right now we cannot say that the velocity is being 0. हम ये नहीं कह सकते कि अब B पर velocity 0 है, because of the body is in motion, and if the body is in motion then there will be the kinetic energy. Why? Because of the body is having some velocity. Now we will calculate the value of velocity. How will we calculate this velocity of VB? मैं यहाँ पे इसको ऐसे थोड़ा सा स्पेस दे देता हूँ। Now from third equation of motion, ठीक है, third equation of motion, we have v square is equal to u square plus 2gh। अगर हम ग्रेविटी के अंदर में बात करें तो हमारा यही इक्वेशन हो जाएगा, क्योंकि फॉलिंग बॉडी है, दैट इज व्हाई वी हैव टेकन द कंसेप्ट ऑफ ग्रेविटी हियर। तो पुट v is equal to vb, u is equal to 0, and h is equal to x. Why we are saying so? Because of the body has traveled this distance x meter or x unit, whatever the unit may be defined. Initial velocity was 0 and the final velocity is vb. So just keeping these values, we will have vb is square is equal to 0 plus 2gx, or we have vb is square is equal to 2gx, right? So now we have the value of vb. We can put this value of vb in this equation. Let us suppose this equation is a, right? This is equation a. Now substituting value of vb in a, then what we will have? Kinetic energy at b will be 1 by 2 m into 2gx. 2 and 2 will be cancel out. We will have mgx. Now this is the kinetic energy at b. This is the kinetic energy at b and this is the potential energy at b. So what will be the total, energy? Total energy at b will be mg h minus x plus mg x. So जब मैं इसको सॉल्व करूंगा बेटा, ये क्या हो जाएगा? mgh minus mgx plus mgx, and what will happen? This 2 mgx having the opposite signature, opposite sign, will cancel out and we will have the total energy at b is equal to mgh. This is another expression for the energy, equation number 2. आई होप यहाँ तक की चीज़ें समझ में आ गई होंगी आपको. हमने पॉइंट ए पर एनर्जी कैलकुलेट कर ली. Again we have calculated the energy at point B. If we see at the both situation, in the both situation, the total energy of the body is same. Yes, the potential energy and the kinetic energy may vary, but ultimately the final velocity is same for both situation. In the same manner, we can have the look at point C. Since I do not have very much space here and I am not going to rub it, I will use this space to understand that concept, okay? So please do not confuse about the mess up. I am just using this vacant space so that we can have all the situation on a single board, right? Now, at point C, मैं इसीलिए इसको किनारे लिख रहा हूँ यहाँ पर, at point C. Okay. If we are going to understand about this, since the point C is at ground, so the potential energy at C will be 0. Why? Because of H is now 0. So the formula mgh, so m into g into 0, so the potential energy will be 0. And the kinetic energy at C will be 1 by 2 mvc square. राइट, mvc स्क्वायर. अब जैसे आपने यहाँ पे किया था ना b के लिए, सिमिलरली मैं यहाँ पे इसलिए लिख रहा हूँ, सिमिलरली फॉर पॉइंट C velocity becomes vc and h become h. तो यहाँ पे वैल्यू रखेंगे तो vc स्क्वायर इक्वल टू 0 प्लस 2gh, और वी कैन से vc स्क्वायर इक्वल टू 2gh हो जाएगा. भाई इसी इक्वेशन में v की जगह हमने vc रख दिया फॉर द पॉइंट c ये h की जगह h हो गया, u तो जीरो है ही. So this is the value of Vc square. Putting this value here, we will have 1 by 2 m into 2gh. 2 and 2 cancel out, so the kinetic energy becomes mgh. और अगर आपके पास ये हो गया, सो आपको पता हो जाएगा भैया क्या, टोटल एनर्जी इज इक्वल टू पोटेंशियल एनर्जी प्लस काइनेटिक एनर्जी एट सी, है ना. एंड दिस रिलेशन विल गिव अस व्हाट, दैट विल बी टोटल एनर्जी एट सी इज इक्वल टू एम जी एच, बिकॉज पोटेंशियल एनर्जी इज जीरो. डन. So this is ultimately the derivation. If we see at point A, the total energy was mgh, at point B, the total energy is mgh, and at point C, the total energy is still mgh. So this manner, or we can say by this way, we can have a derivation of a body does not change, its total energy. Instead of having different total energies, we can say according to the law of conservation of energy, the total energy of the body is still same, either whatever the condition was. Only the variation may be in its potential energy and kinetic energy. Somewhere the potential energy will be zero and somewhere it will be maximum. So these energy are going to interchange from one form to another form. That is why it is further said about this law is energy neither be created nor be destroyed, it just transformed from one form to another form, right? I hope this video will help you to understand about this concept of law of conservation of energy. Okay, thank you very much. If you do like this video, the concept, the way of learning, then please subscribe and share my channel. Thank you very much. Have a great day.